Today we're going to be working on how to take or find the antiderivative of a given f prime of x. So on the first example, we have f prime of x equal to that polynomial, and we're going to return it back to its f of x, or finding the f of x. So we know that in the power rule of antiderivative, if we have x to the n, and if we're taking its antiderivative, it is simply x to the n plus 1 all over n plus 1 plus c. So this is the basic rule that we're going to be using in finding the derivative of problems 1 up until problem number 4. So let's start with 1. So using the rule, all we need to do is to add 1 to the exponent and then divide it by the new exponent. So f of x will be 3x to the 4 plus 1 minus 5x 2 plus 1 plus x minus 2x plus c. So this is the antiderivative of the function, and by simplifying it, f of x is simply 3 over 5x to the 5 minus 5 over 3x to the 3 plus x over 2, x squared over 2 minus 2x plus c. So this is how we use this formula in finding the antiderivative of a given function. Now let's go ahead and use it for problem number 2. Now number 2, we have the integral of 3x squared minus 2 squared dx. So this is another way of finding or writing how to find the antiderivative of a given function. Now since we have an exponent outside the parentheses, there's no chain rule or anti-chain rule for antiderivative. So what we're going to do is to expand the function and change it into a single line polynomial. So we'll have to modify our function by expanding it. So by the distributive property, this is 9x to the 4th. This is negative 6x squared minus 6x squared plus 4. Add this up. Plus 4. So this is now our new function. So the modified version of the function that we're going to take, the antiderivative, would be 9x to the 4th minus 12x squared plus 4 dx. So just like what we did on number 1, since we now have a polynomial, we can simply use the rule and take the antiderivative of each function. So we have 9x to the 5th all over 5 minus 12x cubed all over 3 plus 4x plus the constant c. And if you want to simplify this, we can modify this and change it into 9 over 5x to the 5th minus 4x cubed So this is how we find the derivative of problem number 2 by expansion. Now for problem number 3, we'll have y prime equal to 2x cubed plus 1 all over x squared. So in antiderivative, we don't have a quotient rule for this, so we also modifying y1 by the law of exponent. So we have 2x cubed plus 1 multiplied by x to the negative 2, and by the distributive property, so we'll have 2x cubed multiplied by x to the negative 2 plus 1 times x to the negative 2. And by the law of exponent, we know we can add the exponents with a similar variable or indices. So we can add this up, which will be 2x to the 3 minus 2, which is 1, plus x to the negative 2. So our new function will simply be y prime equals 2x to the 1 plus x to the negative 2. And now we're ready to find its derivative. So using the power rule, y is simply 2x squared all over 2 plus x to the negative 2 plus 1, and negative 2 plus 1 is negative 1, plus the constant c. And by simplifying our function, this will turn into a negative x to the negative 1 plus c, or x squared minus 1 over x plus c. So that's problem number 3. And for the last problem, we'll have the integral of square root of x plus third root of x squared. So there's supposed to be a dx over here. So by simplifying or modifying the function, we are going to use the law of exponent and change or modify this into x raised to 1/2 times x plus x raised to 2/3. And by the distributive property, we have x to the 1/2 times x to the 1 plus x to the 1/2 plus, multiplied x to the 2/3. So by adding our exponent, x to the 1/2 plus 2 over 2, so that we'll have the same denominator, is simply equal to x raised to 3 over 2. And this one, x raised to 3 times 1 is 3 plus 4, 2 times 3 is 6. So this one will be x raised to 7 over 6. So our modified function this time will be the integral of x raised to 3 over 2 plus x raised to 7 over 6 dx. So to take the antiderivative of this function using the power rule, we'll have x raised to 3 over 2 plus 1 all over 3 over 2 plus 2 all over 2 plus x raised to 7 over 6 plus 6 over 6 all over 7 over 6 plus 6 over 6 plus the constant c. And by simplifying this, 3 over 2 plus 2 over 2 will be 5 over 2. 7 over 6 plus 7 plus 6 is equal to 13. And if you want to further simplify this and change it back to its radical form, this can be changed into 2 over 5 square root of x to the 5th plus 6 over 13 6 root of x to the 13 plus c. So this is how we use a single rule in finding the antiderivative of these functions.